So we know how calculus works. There's integrals and derivatives, and they're pretty much direct opposites of each other. And that's what the fundamental theorem of calculus says. If you take the integral of a function and then you differentiate it, you should get the exact same function. So let's take, for example, this function x. We integrate it, and we get x squared over 2 plus c. And then we differentiate it, and we get x by itself. The FTC links the concepts of integrals and derivatives together. For any function that is conceivable, you can integrate it and then differentiate it, and you will get the exact same function as you started with. Let's take this for example. The derivative with respect to x of the integral of t respect to t from 3 to x. Now this might seem confusing at first, but let's take this in chunks. The first part, just the integral. Forget about the derivative. The integral, once we integrate, is going to look like t squared over 2. And we have our lower and upper bounds. Lower is 3, upper is x. So when you plug it in, you have x squared over 2 and 3 squared over 2. Now let's differentiate this with respect to x. So once we take the derivative of this, the constant is eliminated, but the x squared over 2 part turns back into x. So going back to the original function, t, we now have x. All we have done is substituted x for t. So let's take a more difficult problem, for example. The derivative with respect to x of the ln of t squared dt from 5 to x. Now, you might be thinking, first of all, I'm not really sure how to integrate the ln of something. So, what you can do is use the same principle as we did in the first problem and just substitute x. The 5 will go away and the x will be where the t is. You'll have the same function. So try this one by yourself. The derivative with respect to x of the integral of secant squared 5t cubed all over t respect to t from 5 to x. Pause the video and press play when you figured out the answer. And the answer is secant squared 5x cubed all over x. This has been Calc Fun with Thomas. See you next time.